Hi, everyone. Welcome to this edition of the AI Monetization Podcast. I'm Binny, the co founder of ProjectPro. We speak with industry business leaders and researchers on what kind of outcomes they are seeing with AI inside their companies. We have with us Dr. Yao. Yao is the head of AI at Artificial Incorporated. And Yao works on a very interesting use case of a completely AI powered scientific research labs. And we'll hear more about that today. Among our deep experience in AI and machine learning, Yao used to be a staff ML engineer at AMD for many years. And before that, she was a computational chemistry researcher at Rice University. Across her career, Yao has filed multiple patents around, specifically LLM training acceleration. Yao, thank you so much for taking time to do this. Welcome to the podcast.
Yeah, thanks for having me here, and super excited to be here.
Okay. So Yao, you have worked on multiple AI-driven solutions in manufacturing, genomics, material sciences. How did you kind of find your way into AI for scientific labs?
To answer your question, let me give you a brief overview of my background. I did my PhD in computational chemistry, as you mentioned, and during my PhD, I worked with experimentalists from scientific labs on a daily basis. And when I was about to graduate, this is about 10 years ago, over 10 years ago, there weren't a lot of jobs in AI for science because AI was starting to take off, and really the industries you see did not include the scientific domains. So I started working at KUKA Robotics, which is the fourth largest robotics companies in the world. And at KUKA, I worked on predictive maintenance and anomaly detection for industrial robots. So I worked on manufacturing in robotics, and I worked on some deep learning projects as well. And then after working there for a couple of years, I joined AMD, started working on using AI for semiconductor industry manufacturing processes, how to make them better using AI. And also I started to lead different projects in AI for science, including genomics and material science, because those are sort of related to my background. And last year, I got to know the company Artificial, who orchestrates automated labs. And really, it was a perfect fit for me, and because of my background in AI and science. And I really have a huge passion in doing automated labs. So that's why I got into this space.
Amazing. Thanks for sharing that. Can you maybe just walk us through what is a automated lab or a self-driving lab, and how does AI help scientists make new discoveries in such a lab?
When you talk about self-driving labs, what we mean is, well, usually we call it self-driving labs or closed-loop labs. So you start with parameters in your experiments. So you run your experiments, and when you get the results from the experiments, AI models start to kick in. So AI models analyze the results, and then it will suggest new parameters for the next round experiments. So you run next round experiments, you keep going until certain criteria is met. For instance, a certain drug is found based on certain properties. And AI and automation usually are in the loop. So what that means is you don't have constant human intervention. So AI is really helping the whole loop. And when we talk about automation, usually it's robots, robotic arms, liquid handling systems, etc.
I see. Got it. And what role does artificial play in this? What components of an automated lab does artificial provide?
Right. So Artificial is a software company. We work with pharma, biotech, and could be in any industry that has scientific labs. So we provide a digital twin platform that mimics what's happening in the lab.
Mm-hmm.
So scientists can manage their experiments and schedule their experiments through artificial interface.
Mm-hmm.
And not only that, we deal with data silos.
Yeah.
So scientists do their experiments and there's data from the instruments, there's data from the experiments, data from AI models, et cetera, So artificial can manage the data, including data storage and data movement. So that's what artificial does. Yes.
Got it. And Yao, when you say artificial provides a digital twin kind of platform, right? Is there a specific area of experiments artificial focuses on? Is it just chemistry experiments, or is it a broad set of experiments? Like, what is there a focus or?
Right. It's quite broad. It's not just for chemistry.
Yeah.
So we have customers, big customers in pharma and biotech, where they use, let's say, liquid handlers. So lots of customers are in pharma biotech currently instead of chemistry, really because in pharma and biotech, there's more automation. It's much more automated than in chemistry right now, but the chemistry is catching up.
Got it. See, usually we hear of AI automating existing workflows inside a company. Have you come across instances where the entire workflow or the process has been reimagined with AI from a first principles basis and redone that way?
Yes, that's actually a really good question. So one area I can think of is drug discovery.
Okay.
So traditionally, when you think of drug discovery, usually it's a long process, super lengthy and costly. And scientists would do experiments through a trial and error. They run thousands of experiments to explore the space.
Yeah.
And when we use AI, lots of times AI can analyze vast data sets of molecular structures and pathways to predict the potential drug candidates. And lots of times we use virtual screening, which is pure in silico without running experiments at all. And usually it's a combination of computational chemistry and AI, and we can actually predict the best candidates first, and then we use the best candidates and put those into experiments. So from that sense, right? So AI really has changed the workflow. So from a reactive experimental approach to a proactive and predictive one.
Right. Okay. And just to follow up on the digital twin product at Artificial Yao. See, I assume if it's being used inside life sciences and pharma to predict some kind of a molecular reaction or things like that in an experiment. But usually with drug discovery, part of that is also how it interacts with humans, because humans consume the drug. So is there like a human simulation part of Artificial's product as well? Or is it just focused on the lab experiments or?
Usually there are humans in the lab. So artificial can orchestrate everything, including humans, including robots, including your experiments. So it's everything in the loop, right? So humans interface with artificial through our digital twin, and they build their lab. Whatever equipment they have, they can have their equivalent parts in the digital twin, and they can interact with them.
Understood. Got it. Okay. And given that the kind of work you do is at the frontier of AI research, what are some areas that you're personally excited by that you're seeing in AI that we will all see later, but you're seeing? Yeah.
Yeah, that's interesting, right? So I was actually at NVIDIA GTC last month. So NVIDIA GTC is the largest NVIDIA event every year. And at GTC, they announced their most advanced technologies, announce the frontier in AI. So this year, they've made lots of announcements in Agentic AI. And I'm a huge believer in this. And I think Agentic AI is going to take off. It's starting to take off. We still don't see a lot of Agentic AI applications right now, but I really believe it's gonna make a big difference. And what it means is traditionally, when you do AI, you have an AI model. So this AI model would do something, right? So let me kind of make this more concrete. When you say, if you want to do some predictions, and usually you can use an AI model as a surrogate model to predict, let's say, energy for molecular system. But once you have that number predicted by your AI model, we as humans have to decide what to do. Is this number good? Is it bad? Do I have to rerun something? Do I have to improve the model? So I have to make the decisions. Now, agentic AI, the huge difference between agentic AI and traditional AI is agentic AI can make decisions based on the resources it has. So it actually does this job that we humans can do. So it sounds a little scary, but it's coming up and it's really exciting.
Very interesting. And yeah, when you think about agentic AI, right? Your mind, what is the kind of a definition? How is an agentic use case different from a workflow AI kind of thing? Is it the autonomous part of it? Is that the biggest difference, or?
I would say yes. So because of the fact it can make decisions, usually they're based on large language models.
Yeah.
It's trained on all these resources, right? It can make decisions and decide what to do next. Yeah. So that's really a huge improvement.
Got it. And when you build any AI product, or even probably what you're building in artificial, every time some advancement or a new foundational model comes out, how do you think about you using its capabilities the most? Do you immediately switch, get the latest model? How do you think about that?
Yeah, so usually I take a look at the new model, and usually they come with some sort of applications. So I look at those applications and see what advantage the new model is doing on these applications, and see, can it make something previously impossible happen by adopting these type of models. So I'll evaluate that way, and sometimes it applies, sometimes it doesn't. So it really depends.
Got it. Okay. And do you feel, in terms of outcomes, AI is delivering the kind of outcomes people are expecting inside enterprises, or is it not delivering? What do you think is the gap? How are people perceiving the value from AI today?
Yeah, that's a good question. I think overall, AI has been helping us quite a bit, right? It's happening everyday life, like, talking to our cell phones to get an answer, all sorts of things in our daily lives. So generative AI, usually powered by LLMs. And same thing in scientific breakthroughs, right? So you don't see this 15 years ago, but now it's happening. Like every field uses AI to help their science. And lots of times what these models can do is, the process is like, well, when you do traditional simulations, say in computational chemistry, computational biology, computational physics, etc., we write equations, and we use either analytical solutions or numerical solutions. And if we can't solve the problem exactly, then we do approximations. But approximations can't capture or get the exact answer. And when you use AI, lots of times is neural networks. What it does is it can actually capture interactions that physics models can't. So it can make improvement, right? So we see that a lot in scientific breakthroughs, or really they can change how we solve problems completely. So I really think AI is doing a fantastic job.
Yeah.
Of course, there are gaps, right? So we have to make decisions, as I mentioned earlier.
Yeah.
And now Agentic AI is going to fill that gap.
Yeah.
And there are so many things in, when we talk about self-driving lab, this closed loop labs like this domain, you still have to have humans in the lab. I'm not aware of a single lab in the world that doesn't have humans in the loop. So yeah, so currently I really think that's the gap, and we're gonna fill the gap.
Got it. Makes sense. And you have been doing AI research and applied AI for a while right now, and you've seen, it used to be called data science, machine learning, AI, and the latest flavor of that is Gen AI right now. And from what we understand, the insight or the breakthrough that OpenAI had a few years back was that they noticed that as long as you kept increasing the compute and you kept increasing the amount of data, the models that got better and better.
Right.
Would you say that is a fundamentally new insight that OpenAI got, or was that knowledge always available, but people didn't have the ambition to spend so much money to train these things? Or was it a very new insight?
Right. Let me rephrase your question to make sure I understand right. So if I hear you right, you're saying OpenAI is training larger and larger models, and other companies are doing this as well. So is this a new thing, or is this not a new thing? Is that what you're asking?
Yeah, I was just asking, being an AI researcher, this insight that if you kept increasing the compute and if you kept increasing the amount of data, the models got exponentially better. That insight, did most people in AI research, did they know about it 5 years back? Or is it something new OpenAI found themselves? Yeah.
Yeah, I think people know it.
Yeah.
It's really the resources.
I see.
Not a lot of companies are able to afford to train big models. That's why these big models come from big companies like Meta. So Meta has Llama models, and you said OpenAI and NVIDIA. So all these big companies, they are able to do that. But usually you don't see this from normal companies, right? Yeah, but lots of times, people do. Actually, I see this quite common is instead of training large models, what companies do, I mean, when I say companies, these are normal companies, enterprise companies in other industries, maybe. So they actually do fine tuning, or they use a retrieval system. So lots of times these models are very well trained, but they're not applicable for certain domains, and you have to use these models for your specific applications, so that you have to do these sorts of things.
Makes sense. Okay. And what are some of the key problems in traditional labs that artificial solves with AI?
Yeah, good question. Lots of the pain points in traditional labs are related to the processes, human error, reproducibility, data overload. So let me kind of walk you through different areas. So when I worked in grad school, I worked with experimentalists in the labs, and they were doing manual pipetting and data entry and do sample prep and all these things by hand. So it's very time consuming, it's not accurate, and you still see a lot in academia and some in industry, and industry is much better compared to academia, in my opinion, in terms of automation, right? So automation really streamlines this, and they optimize the workflows. They make these more accurate. So you improve that, and then you reduce its human error as well.
Okay.
But another problem that comes with it is data silos, or data overload. So I was at a conference in drug discovery last year in Boston, and I met different people from pharma, from biotech, and everybody complained about their data silos. So they were like, oh, I have all these instruments, and some are liquid handlers, and they're able to run them in this super automated fashion, but then they'll have data. They need to get data off the instruments, off the experiments. And then what do you do after that? If they want to train their machine learning models, you'll have their AI team to do that. So another thing I see is different teams need to talk to each other, and the data needs to be flowed sort of in the whole cycle, but it's really not. So imagine you have data science team, machine learning team, automation engineers, and scientists, and all these people, they copy and paste data, they package data to each other. So that's really not efficient. And what artificial is doing is artificial orchestrates the whole lab, including AI models. We integrate AI models into the workflow, and we are able to capture data automatically, timely, from your experiments while you're running the experiments. So everything is done in this automated fashion, and it really solves the problem, and we manage the data. And now we're actually building agentic AI solutions to help our customers. Say a customer, if they run experiments, they can schedule the experiments, and if an error comes up, traditionally what they do is they'll search the error message in their documents. Usually they have tons of documents to go through to find a certain error. And what we have is, we're building this, is gonna go to production pretty soon. So we will have this feature, which is a knowledge bot. And when a customer has an error message, then they'll be able to search or talk to this knowledge bot, and then we can help them find these documents automatically and tell them what to look for. So things like that really help customers in practice.
Very interesting. And could you give us an example, Yao, on what is an example of a sample experiment that a researcher would run on artificial, like an experiment statement? What would a sample experiment look like?
Yeah, so a sample experiment, like let's say DNA synthesis, or I'm really making this up. So if the audience has biologists, they probably will laugh at me. But say really anything they do in the lab, from DNA synthesis to small molecule generation, whatever they do, you'll have all these design experiments, and which includes different steps. So you'll have different steps in this artificial interface, and really what they need to do is to click run, and it's going to run. It's going to show them in real time what's happening, what job is running on what equipment. And also we have this scheduling feature, which is if certain equipment is down, is offline, then the system can decide what to do to switch to another equipment or something in real time.
Very interesting. And the one other thing, Yao, is that typically when I think of scientific experiments, right? Usually, I guess people expect very precise results or very precise measurement from scientific experiments. But now when you use language models to power these experiments, how do you balance the need for accuracy versus the fussy probabilistic nature of these foundation models?
Yeah, that's a question, right? We've asked ourselves, how do we make sure we provide accurate answers to our customers if we use LLMs? So we actually have built an evaluation system, and oftentimes they're ground truth Q&A question answer pairs, and we have those to measure different criteria, such as ground truth, trustworthiness, and all that. So we actually have taken that into consideration.
Very interesting. Now, in areas like material discovery and genomic research and drug discovery, right? What kind of contribution has AI fundamentally made in research in these areas currently?
Yeah, I think that's a good question. It's super broad as well. Let me kind of go through different areas because I've worked on all these areas you mentioned.
Yeah.
Small problems or big problems. So for materials discovery, a lot of times I see property prediction is quite common. We want certain materials that have certain properties. So in this case, you predict the properties. And then inverse design is actually a big thing. And, so let me explain what inverse design is. So usually you want to find a material that has a certain property. So you ask, what material can fit this target property? Traditionally, you look at all these material space and you're trying to do experiments, trying to make the material. But now what we do is oftentimes we use generative models. So we look for materials that may not even occur to us. We can't even think of, but they're qualified to have certain target properties. So that's how AI has accelerated materials discovery. And of course, there's more, right? Like autonomous labs apply a lot to materials discovery. And, a big player is University of Toronto, and we work with them in some projects. For genomics, a lot of the research in this area is focused on sequence analysis for DNA, RNA, and protein, and you can predict some certain functions. And also, I'm sure you've heard of personalized medicine. So all these, are powered by AI. And then the third one is drug discovery, small molecule generation, using generative AI to generate small molecules. We actually did a proof of concept with NVIDIA recently with NVIDIA BioNeMo team. And one model so it's a virtual screening proof of concept in a self-driving fashion. And we showed that we can orchestrate that workflow through artificial. But one step in that is molecule generation. So there's a model, Momin, that generates new molecules. So that's one application. And of course, you have target prediction. Lots of times you want to find drug molecules that have certain solubility. So that's another application I see quite often. And of course, I mentioned virtual screening, and there's so much more. So.
And finally, could you talk a little bit about what role does robotics play in an automated lab, and how does an AI-powered automated lab integrate with more hardware robotics?
Yeah, so I think we've covered a lot about the AI part, right? So another big part is robotics and automation. These are related, but they can be seen as separate as well. So robotics, usually we're talking about automated platforms such as robotic arms, liquid handlers, etc. So they can do experiments high throughput experiments. They power high throughput experiments, and you can get high precision and reproducibility. It removes lots of human errors we talked about earlier. Automation has robotics in it, but in my opinion, it has more. So you have like scheduling and orchestration, and that's what artificial is doing. So we manage the experimental pipeline, so we connect everything, and you reduce the time doing things manually, right? Compared to doing things manually. And we have the digital twin that basically mimics what's happening in the lab in real world experiments.
And just a final question is, for fresh graduates getting into AI and machine learning, what career advice or career guidance do you have for them?
Yeah, it's really like exciting time to be in this field, to be in AI. And, when I look at hiring new grads, right, one fear I have is they've done some awesome work in applications, in using, let's say, LLMs. But one fear I have is, do they understand what's going on? Do they understand the math? So I really value people who understand what's going on. When we talk about LLMs, oftentimes they're transformer models. Now, how do transformer models work? Attention layers, like these things, you really go deep. Then you understand, why do we have certain parameters when we, use an LLM? So these will actually, these are the skills I think that are lacking in the younger generation.
Makes sense. So more focus on like the foundational working of these models and not just applied AI.
Yeah.
Okay. Makes sense. That was super helpful, Yao. Thank you so much for taking time to do this. Very insightful points. Thank you.
Yeah. Thank you so much for having me. I really enjoyed this.
You're welcome.